lazy computer scientist. I don't like to remember anything. I just offload all my memory work to Google, because that's where all the information is these days, right? So when in doubt, and if I'm thinking, how the heck do I convert a temperature from Celsius to Fahrenheit? Oh, look, there we go, it tells me. You take the temperature in Celsius, you multiply it by 9/5, and then you add 32, which is basically the opposite of what you said. Let's make sure this is recording. All right, cool. So based on this, let's go over to our collab. So let's say we have C equals, I don't know, what temperature is it outside right now? Oh, yes. All right, well, I've been lucky so far. Here's hoping it doesn't go all to hell. All right, so you're not alone. Good. Any other questions? Now's a good time. Yeah.
Approximately when we'll probably have the skills needed to start the first assignment?
I'm trying to think. When will we get to ifs? Fairly shortly, but I won't set the deadline until it's there. And also, you may have noticed that only just before class, if you look at the assignments, okay, by the way, if you're ever using, okay, some browsers will cache web pages. This is an old version of this web page. So constantly be refreshing your pages just in case. There we go. Due date is TBD. The due date that was posted was last year's. I just never got rid of it. So that's, if you were thinking of that deadline thinking, uh-oh, yeah, don't worry, it's TBD. I'll set it once I get a sense of how far we'll go. Okay. All right, we were moving Celsius to Fahrenheit. So Celsius, what temperature is it outside right now, approximately? Let's call it 18, because that's what I heard. So Fahrenheit will be equal to C times, what was it, 9/5?
Yeah.
9/5 plus 32. Oop. Oh, and I guess I should print F. $64.4, is that right? Let's see. 18C to F. 64.4, wonderful. So look at that, it worked. Great. Okay. I'm going to tell you a bit of a story. Maybe story isn't the right word, but I'm going to tell you something that really, really angers me as a programmer. In many, 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 many programming languages, including Python 2, which was a previous version of the Python we're using now, which is Python 3. In many, many, many versions of popular programming languages, not even versions, in many popular programming languages, whenever you do division on integers, it'll only give you an integer back. But as you can see, if I go here and just do print, it's 1.8. But if this was Python 2 or Java or C or something, and I typed 9 divided by 5, the answer would be 1. Any decimal place is ignored. The answer could be 1.99999999999, but because the result's got to be an integer, it ignores the decimal. It won't round, it'll just ignore the decimal. Python 3 came along and changed this convention, which angers a lot of people. I hate this. I hate that they did this, because the default functionality is integer division. It truncates any decimal. But Python 3 comes along and goes, I'll just turn it to a decimal for you. But there are a lot of instances where I might very intentionally, and we'll see a bunch of these examples in 162, there's a lot of cases where I specifically want that integer division. I don't want any decimals. I want it to truncate and just pretend no decimals exist. There's a lot of cases where that'll happen. Imagine you had all this code written in Python 2, bajillions of lines of code that had integer division in it. Suddenly you upgrade your Python, you try to run it again, and everything's going to go to hell because you're expecting it to do integer division. But it's being nice and doing floating point for you. An easy fix for this in a language like C or something is if you just turn them to floats. And then it'll do the floating point division. But in Python 3, you don't need to worry about that. Part of the reason I'm telling you now is, raise your hand if you've programmed before but in a different language. Okay, so this will get you if you're used to integer division. Also, next semester, it'll come back to bite you again. If you really want integer division in Python 3, what you do is you do 2 divides in a row. See? I could do 1, 2, 3. And it's going to come out as 0, even though it's going to be like 0.9999 and so on. I saw a hand.
But why would you want it like that?
Though there are a bunch of cases where we would want it. Once we start learning about lists and stuff, we'll see a bunch of specific examples.
Okay.
I just did like 3 of them, but I wish I knew about.
So with the reason people are a little ticked is they made this double divide the integer division, even though the default behavior for many other programming languages, including Python 2, is a single divide. A lot of people argue that, okay, fine, you can do integer division, but why didn't you make the integer division, which is the weird one, the 2 slashes? But anyways, just a warning. Regular division, yeah. Cool. So are operators just for numbers? Some people were playing around with this. Well, we already saw what happens if you say hello plus world. Oh. The plus on strings means concatenate. So, it looks like these operators are type dependent. If I had 2 numbers and I said addition, it means addition, or plus sign, it means addition. If I have strings though, then the operator just concatenates them. If I try to do this, no, it's not going to be happy. Here's a funny one. Check this out. Take a wild guess how many hellos there are. 10. What gave it away?
Multiplied by 10.
The times 10. So that's pretty cool, right? It's just like, okay, concatenate it with itself this many times. I mean, if that's the case, can I do divide? No, because what on earth would that mean? Yeah.
Why does it, what's it
Concatenate,
concatenate?
yeah.
There's no plus sign. Didn't you say that?
Because the multiplication means like, do the concatenate 10 times. In the same way that multiplication means like repeated division, or repeated addition in math. But yeah, so that's why. So there's no plus sign here, but it just means, okay, just concatenate it with itself this many times. In the same way of like, add 5 to itself 10 times. Cool. Whoop. So that's pretty neat. Okay, all right, so most of our programs so far, especially if you have been programming explicitly or specifically in an interpreter, which most of you haven't, if not, no one has, you've been programming in Colab. Single line programs are great and all, but they don't do very much. We're gonna want probably chunks of code to do interesting things. So, we just write our code. like this. 3 lines there, great. If we were programming on our computers, not on the cloud, we would be programming in like a, here, I'll open up Notepad. We'd be programming in a simple little text editor like this. And I'd say like, okay, C equals 18, F equals C times 9/5 plus 32, I guess it was, plus 32, print F, right? So I would just write the code in this text file, and then I could save it and run it on my computer. And that'll work just fine. But we're not really doing it that way. We're doing it in Colab, which makes things a little easier. But if you really wanted to, you know, write the scripts on your computer and run them, great, yeah. Why wouldn't you do it in IDE? Why wouldn't I do it in IDE? We could. There's no reason not to. Yeah, okay. So, I think I'm gonna skip this activity, but feel free to do it. But we all should, this activity at this stage, you've learned everything you need to know, and there's no real tricks to it on how you would do this. And there's a video there showing you the details. Consider the statement, Def Leppard is a poor substitute for Van Halen. It's just a string. If I told you, assign each individual word to its own variable, and then concatenate all those variables together and print out the result, you should be able to do that by now. Just you take each variable that contains the strings, put them in the right order, and throw in a bunch of plus signs. You'll have to deal with the spaces, so maybe you want to also concatenate little spaces between each variable, but yeah. Okay. Any questions now before I start talking about functions? Yes?
When I was doing the temperature, I wanted to print out like it's this many degrees Celsius, like in the thing, you would have to have it, you would input a variable. Is there a way to have text, a variable, and then more text in the same line?
Yes. But let's not worry about that right now. Good question though, nonetheless. Other questions? All right, so functions. All right, raise your hand if you've ever heard the word function before. Everyone put up your hand, because I know you've taken at least math at one point in time. You've written a function like f of x, right? You've done that. That's a function. It's a math one, but it's a function. We can write functions in programming languages too. It's the same idea. You give the function a name. In math, you know, the default is f. That's the name of the function. And the function might have parameters like x, right? If I wrote the function f of x equals x plus 1, and I told you, okay, calculate f of 4, what's the answer? Everyone yell 5. It's not a trick question. It is that simple. 5. Why? Well, okay, well, fx is 4. 4 plus 1 is 5. Done. I mean, I can have more variables if I wanted. I could do like x and y. There. Right? Ultimately, what is this function doing? Just addition of two variables. Two parameters, whatever we want to call them. So that, I mean, that's a function. And we'll learn how to do them in code. And there's a lot of reasons why. Imagine you've got a job to do, and this line, this chunk of code right here is critically important for your business. Okay? Good. This is very important code. In fact, it's so important, I'm going to come here and do this. Okay, the answer is 5. Great. But then, my boss says I got to do the same calculation 2 more times, but with 9 and then 8 instead of 10. Okay. So I guess, I mean, this isn't too bad. I could just paste it, and then turn that to a 9, turn that to an 8. And I run it there. Okay, cool. I mean, no big deal, right? I can make those little changes real quick. I mean, there's a lot of repeated code, but whatever. It's easy, find, replace. Okay, so I do that. So now they said that, wait, what do we have here? Instead of dividing by 4, we should be divided by 3. Okay, so see all these divide by 4s here? Guess I'm gonna have to replace them with a 3. Okay, 1, 2, 3. Oh, I made a mistake. Look at that. I even forgot to change the last one accidentally. I gotta fix that. Turn it into a 3. There we go. Cool. So those are the calculations that need to get done. It's critically important. All right, so I change it. Great. But they come back and say, all right, our business is scaling up. Call this function 18 more times and change it back to a 4. Don't divide by 3, change it back to 4. It's kind of getting annoying, right? There's got to be a better way. Well, yeah, there is. We'll write a function. We will write a function that will do this calculation for us. We can write the function once, like this, and then I can constantly use that function. Like if I said, let's go back to the simpler version. Or I guess not. If I give you 4 and 1, what's the answer? 5. This should not be difficult. Why? Well, because 4 and 1, well, that's 4 plus 1, 5. And then I could, I wrote this function once, but I can call that function again and say, what happens if I give you 7 and 3? What's the answer? What if I give you 10 and 1? Say it again. People are very unsure of what 10 plus 1 is, I guess. Because I heard, So the point is, I can write the function once, but I can keep using it however many times I want. It's fantastic. I mean, when I write the function, the function currently, when I write it, doesn't have a value. It's not doing a calculation. It's just a statement of what a calculation would be if I ever wanted to use it. If I'm just looking at f of x and y equals x plus y, and say, okay, here you go, and you're like, okay, great. But until I give you an x and a y to throw in there, there's no number crunching to do. So, we're gonna write functions. And a function is a nice way to group logical, cohesive, important chunks of code together. We can write functions however we want. Having to know, should there be this many lines of code in this function or that many? It's up to you. It doesn't matter. Whatever makes sense for what you need. So if I had a very, very, very simple example here. No, copy. Who remembers last time that def keyword wouldn't work? Of course you remember. So def, what are we seeing here? Def, who wants to take a wild guess at what that's short for? Definition, define, yeah. Same thing. So we are defining a function. And I am calling this function my underscore function, but I can call it whatever I want. This is kind of like a variable name. It's whatever we want to call it, except this is the name for that function. There. I called it, this really is my function. I could call it that if I wanted. The fact that it's called my function is it's arbitrary. I'm gonna put it back though for simplicity. And then within the parentheses, I could have parameters. Just like this, x, y, values that I could give to the function that the function would need in order to do some number crunching. So it looks like what we're gonna do is this function takes a value. What does it do to that value? It doubles it, puts it in B, and then it prints out B. So, what is this function effectively doing? It's not a trick question. If I put in the value 4, what would come out? If I gave you the value 10, what would come out? So what is it doing? It just doubles the value that you give it and prints it out. I mean, it's a fairly simple, kind of not that handy function. It's just an example. But watch, I'm going to run this code and let's see what happens. Nothing happened because there was nothing to do. All Python saw was, oh, you're defining a function. Great. It's like I wrote this. If I want to use that function, well, then I call it. So I would say like, okay, well, my function, 55. And what should I see printed out? 110. Why? Well, 55 replaces this. This is 55. What's 55 times 2? 110. Put it in B. Print out B. If this is freaking you out, let's make it look more mathy. F. X. There. So like here's the definition of it. It's like the idea to match like a simple f of x. And then here I'm calling it. And I could call 66 f that number. F -3. And it prints out all the answers for me, which is great. So I wrote the function once, but I can call it however many times I want here. It's fantastic. It's cool. All right, so if we use the function, yeah, perfect. Oh, also, because we know what happens when you do a multiplication on a string, this would have the interesting consequence of concatenating the string with itself like twice. So James. Cool, right? Should be handy. So when we call the function, when we're calling it, that's when Python actually executes the code in the function. When you write it, all you're doing is telling Python, hey Python, here's a function called my_function. It takes a parameter, and then when someone calls it, what you're going to do is you're going to double it and print out the result. And Python goes, okay, great. But until we call it, that code's not going to run. So real quickly now, if you've got Colab open, write a simple function and just do whatever you want. And then call it a couple of times. Have your function take a parameter or two, I don't care. And just get a function working and be satisfied with that. Or raise your hand if you got a function working. Raise your hand if you need like just 2 more seconds, you'll totally get it working. All right, so I wrote a function here. Have a look at my function and see if you can think of what it does.
It would put with the number of pages as the number you put into the equation.
Into the function, yeah. So let's have a look. Let's see if you're right. Blah. Come on. So let's see if you're right. Looks about right. Yeah. Why did I write this function? I don't know, because.
Why not?
Yeah, exactly. Because why not? Often in computer science, let's see what happens if I do this. Why? Yeah, I don't know. Why not? It's a good attitude to have.
Because I want it. There we go.
So, the parameters we include in the parentheses at the top. And we can have a bunch of parameters. I showed an example of 1. We can have 2, 3, 4, 5, whatever. But, you know, we want our functions to be very general. In the sense that, imagine I told you, write a function to add 2 numbers together. Would it make sense? Like, would this make sense? Okay, I'm going to go down here. Def add 1. Def add 1, 2. Def add 2, 1. You know, and so on and so on and so on. It's kind of stupid, isn't it? Why would I, like, that's kind of annoying. We want our functions to be general. I could improve this by like, okay, well, what if I do this? Add 1 to x. X. Add 2 to x. Oh, no, I guess this should be 3. X. There. I mean, this is an improvement now, right? Because I don't need to write 1, 1, 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, 3, 2. I don't need to write all those. Like, it seems as if I could like almost like half the number I got to write here. But of course, we can go a little bit further. Just one sec. We can go a little bit further and say, well, why don't we just do this? And then print out x and y, and then I don't need any of these anymore. There. Now it's much more general. I gotta have one function to cover all those cases, which is way better than writing out just like an infinite number of these functions for adding any possible combination of 2 numbers. Yeah. Okay. So, these parameters help us generalize our functions, and we like our functions to be very general. So this is a great one for adding. You might say, well, why did you write that function? Just use the plus sign. You're right. But this function does add, right? So if we go back to that example before, at the top, remember when I was defined like, okay, divide it by this, divide it by that, do it 18 more times and all that. Well, we can improve that scenario by just writing a function. There. I hate my boss. So here we go. It's now in a function. If I want to run this code 18 times, I can just run it 18 times. But we can generalize it. Because remember, well, the number being divided changed a couple of times, and the number we were dividing by also changed. So why don't we, do something like this? And then now, uh-oh, that'll be bad. Did I just hear Z? What's Z? Oh, do you mean Z, the letter based on the Greek letter zeta, not zeta? I'm just teasing you, of course. So there we go. Now, it's much more general. Now, if my boss wants me to divide by 3 instead of 4, all right, well, I just call I hate my boss 10, 4, and then if I want to do it with 3, all right, well, I could just do it immediately again, but with 3 instead. Then I can do it again with 43, I guess. Like, boom. Great. Fantastic. Way better, right? I don't need to keep copying and pasting and changing those values, accidentally missing a value that I meant to change, and then suddenly, why is it working 99 times out of 100? Oh, there was a typo. That redundant code, of that code doing the same thing, that could become a problem. Because if your program's huge, and then you make a change here, and you would have had to change it in 3 more other spots, wouldn't it be great if it was all in one spot and you only had to change it once? You eliminate the risk of all those bugs in your code. Ugh. So that's what we were doing it there. Great. So, and like I was saying before, this is just like your math class, except the notation we use, the syntax we use for writing the function's a little bit different. In your math classes, you'd write it like something like this. In Python, we start by saying def, function name, parameters, which is kind of like the same, and then colon, and then whatever in the body. Yes?
Do you make up your own function name, or is it something that's already?
You can call it whatever you want, like I hate my boss. There are some restrictions, like you can't call your function def, because that's a reserved word, just like it was for, actually, can you? Okay, good. Good, thank God. There are things, though, where you can accidentally overwrite other functions. Like, if you want to mess something up, say like print equals I hate my boss. Now you're in trouble, because if you ever try to call print, it's just going to call I hate my boss, because I made the functions equal, but let's ignore that. And that's actually going to be a problem if I call this, because what happens when I hate my boss calls print, which just calls I hate my boss? Uh-oh. Let's see what happens. Oh, I'm missing something. Oh, because it needs new 2 parameters. Let's give it y twice. What? I just put it there. Missing 1 required, whatever. Now I'm just being silly. Anyways, yeah.
I think what's happening.
I'm not really asking a question about what's happening here. I'm just showing you something. Well, we'll talk about this later in the course. We will talk about interesting, funny things we can do with code.
How do you undo that, though?
You do runtime, restart runtime, there. This will just clear everything out and forget it. It is a good thing to know. Runtime, restart runtime could be very handy. So, another thing we'll notice is the code that's in the function is indented. The code that I want to be a part of the function must be indented. That's how Python knows, oh, this code belongs to that function. And if the code's unindented, it's not in that function. So, for example, I have add here, right? So that code, this code right here, let's make it even more x plus y, just overly verbose. So I've got 2 lines of code in this function. You have to be careful. If you want this print to be in that function, but I write it like this, it's not in that function as far as Python's concerned. This is. If I do this, it might get mad about inconsistent indents. Unexpected indent. It's saying, well, there's no need for an indent right here, and I see an indent, so something's wrong. So if we want our code to be in the function, it better be indented, and your indentations better be consistent. Also, if you're using Colab, this won't hit you, but if you're using some other text editor, never, ever, ever, ever mix tabs and spaces. If you do like space, 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 space for your indent, and then on the next line you hit tab, which is like 4 spaces, Python will yell at you. Pick one or the other, never use both. But if you're using Colab, that won't ever affect you. Other programming languages have different strategies for including code in a function. Some programming languages will have like squiggly brackets like this. Right? And that would mean that, well, okay, here's the definition beginning and then it's ending. In Python, it's just the indent. Conveniently, even in languages where you use this, you would still indent by convention. You don't have to, but you would still indent by convention just because it becomes a little easier to read. But in Python, you know, 2 birds, 1 stone. You indent it, it means it's in there, and we'd want to indent it anyway, so it's handy. So this might be, if you're used to other programming languages, this might be one of the things that kind of gets to you, but you'll get used to it pretty quickly. All right, so the call add print 5.2 gets handled like this. Okay, so if we go back up and look at this example, here's the definition, here's where I'm calling it. It's not until I call that function that I actually jump up to the code. If I go here, and then down here, I better get rid of these, because that's not proper Python syntax. If I run this code, let's think about what happens. When I hit run, okay, it's gonna work, great. But Python's gonna start like this. Python starts on line 1. Our programs run sequentially. We might jump to other lines of code, but we always start at the beginning and go line by line and follow the instructions. There is no secret to this. When in doubt, follow the lines of code precisely. Never make any assumptions about anything. So line 1 runs, and Python goes, oh, def add. Oh, they're gonna define a function called add that takes 2 parameters, and I guess it does this. Great, cool. Line 4, nothing there. Add, oh, okay, so they're calling a function called add. Where is that? Oh, it's right here. Let's jump up here. Whoop. Great, add. X becomes 1, Y becomes 1. Then we're on line 2. Z equals X plus Y, which is of course 2, and then print it out. We're done. Return to this line of code. That line of code is now done. Go to the next line of code. Oh, we're calling the function add. Jump up to line 1. X becomes 4, Y becomes 5. Next line of code, 4 plus 5. 9, print it out, return to that line, go to the next line. Oh, well, we're done anyways. So we start at the beginning, but we might, you know, jump around, because if we're doing a function call, we'll jump to those lines of code in the function. Any questions about any of this so far? Yeah?
So we could either do all of that in the same cell block, or we could wait until a few cell blocks.
Yeah, you could put them all in the same if you want. You can put them in separate ones, but you gotta be careful, because if I do this, x, y, and then say print x minus y, for example, and then I go down here, and then I call sub 6 and 1, and I hit run, it's not gonna work. Bingo, because I never ran this code. So if I run this, now Python goes, oh, I know what sub is now. And then here, it's 5. 6 minus 1 is 5. So you just got to make sure that the code that you want to run has or is running. I know it seems obvious, but it's one of those little catches on Colab because we do have those cells. Oops. Okay, all right. What happens if we don't give it enough or too many parameters? Well, sub takes 2 parameters. What happens if I give it 1? Who wants to take a wild guess? It'll say I'm missing an argument. Argument parameter. I'm missing one. It's called y. Where is it? What happens if I give it more? I only want 2, you gave me 4, something's wrong. You as the programmer messed up. It's letting you know. So I go, oh yeah, you're right, I guess I'll get rid of those 2. All right, it works now. Cool. All right, so we won't actually do this activity, but we can get an appreciation for it. If I told you to write a program on paper, not actual code, but pseudocode, like step by step. Did I explain pseudocode is basically code that's somewhere between English and actual code. It's designed to be generally readable, it's programming language independent. I could look at the code and turn it into Java, Python, C, whatever. But it's also readable enough that someone who might not even be a programmer could kind of follow along. You know, it's funny, a recipe is an algorithm. I'm not being silly, it is. You start at the beginning, you follow the instructions, and at the end of the day, you get a cake. It's a pretty awesome algorithm. Directions. Think of the directions you take from who drove to school today? Oh, most of you walked? Are a lot of you on campus? Yeah. All right, yeah, I guess that makes sense. Well, if you drove today, you know, there were some directions you followed. Maybe you pulled out of your driveway, turned right, turn left, turn right, you know. That's an algorithm. If you're starting here in this current position and you follow these steps, you'll get to where you want to go. I'm not being silly. Those are algorithms. Obviously, it's not a computer code algorithm, but it is an algorithm. So, if I told you to write an algorithm, write a program to make spaghetti, but the only things you were allowed to use was locate object, like locate pot, locate tap, grasp, release, move limb to, wait, right? If I told you to write a program only with those instructions for making spaghetti, it'd be kind of a pain in the ass, right? Like, hey, locate pot. Move limbs to, I guess move limb. Grab, move limb, release, you know, that's going to be a pain. But like I was talking before, we as humans operate on, a bunch of different levels of abstraction. I could tell you, boil some water, throw in spaghetti and some salt, and then wait 10 minutes. And chances are you'd probably end up with spaghetti, right? Because you don't need to be that precise. We can operate at a level of abstraction much higher. Just like print. Someone needed to think of the level of abstraction about which pixels to turn on your screen. But I don't. I just say print A, print B, and then it works. Because I don't want to deal on that level of abstraction. I want to be able to drive to work without having to thinking of the inner workings of an internal combustion engine. Because you know what? I don't care. All I care about is that it does its job, and it gets me to work, and I'm happy. I don't care about that more detailed level of abstraction. So we operate in different levels of abstraction. Imagine you have this really complicated stuff, like print. You're writing the function print. Someone wrote the function print, right? Raise your hand if you've used the function print. Did you write the code for the function print? No. But somebody did, because it works. So we're calling the function print. So someone defined it. And with that, all the details eventually got worked out for turning on the pixel. And that function exists now. And now, if I ever want to print, I just call that function. So I don't need to worry about writing that level of detail all the time.